Hi everyone, my name is King IV, and this is Introduction to IDEA Data Analysis by Caseware. This is the final video in a series of 8 videos covering the topic of Introduction to IDEA. In today's lesson, we'll be covering Introductory Statistical Analysis using Caseware. The two files that we'll be using are Country Admissions and World Total Admission, and these files can be found in the Dropbox link here, and as well I'll be including in the description below. So let's get started. So what you'll have here is I've already imported the data, country admissions and world total admission. And when you'll see country admissions, you'll see the country, the year, and the total carbon emission for that country for that particular year. And then what you'll see here in the world total emissions, the year, and the world's carbon total emission. So the first thing that we need to do is perform a join. We're going to join. We're going to use the country admissions file as our base file, and then world total admission as our secondary file. And we just need the total field from the other data set. So we're going to call this country admission with total. And we're going to be matching it based off of year. And we're going to be including all records in the primary file. Press OK. Now essentially we have the same data file as we did before, except for it includes total. And what you'll see here that as you change years, the total carbon emission changes. So what we want to find out now is, are changes in carbon emission in the countries correlated with total world carbon emission? So we're going to do correlation. We're going to be correlating carbon and total. I'm selecting audit unit. Select country. Sometimes when you select country first, it won't show it up. So you might need to fidget around with that. And we're going to include all audit units. We're going to create a result, and we're going to create a new database. So once you've done that, we'll press OK. And then what you'll see is we'll go to click on this graph. You'll see that there are some countries that have very high correlations, almost 1 positive correlations, and you'll see there's countries that have negative. So when we go back to the data, you'll see, for example, that Belgium has a negative correlation. And let's double check that answer. So it's always good to double check your analysis by reviewing some of the data. So let's go down and find Belgium. So what you'll see in Belgium is that carbon is generally going down, fluctuates a bit, while world carbon emission is always going up. So you'll see that there is a negative correlation trend there, while countries such as China have a very positive correlation. So if we were to go and find China, what you'll see is that China is always going up and the world total carbon emissions going up at a similar rate. So that's great. That's one set of analysis that we can perform. But now we want to figure out how good is the predictive capabilities. Is there a trend? Is there a linear trend? So as time elapses, can we use that formula to predict what the carbon emission will be in 2015, 2016, etc. So we're going to go back to the total country emissions, and we're going to use the extract. So as you can see, we're using all the different analyses that we've learned over the past 7 lessons. And we're going to click direct, and then we're going to go pre-2004, and that's where year does not equal 2004. And then we're going to go year 2004, and that's where we're going to make it year 2004. So what you'll see here is that we're essentially taking the first 19 data points and seeing how well it predicts the 20th data point. So now we're going to have these 2 tables. That's great. And what we're going to do next is we're going to go to statistical analysis. We're going to go trend analysis. And what you'll see is we're going to go trend on carbon. Select the particular audit unit there. And then we're going to generate a forecast. And we're going to just generate it for 1 year. You can do 10 years if you want. But in this case, we're just going to do it in 1. And we're going to create a trend database, create a forecast database, and create a MAPI database, which is basically the mean absolute value discrepancy. So how far do each of the data points deviate from the trend, and what's the square of that. So we're going to go there, we're going to include all the fields, so press OK, and then you'll see it creates a series of data sets. Then you'll see, for example, you'll see the trend analysis for Albania. You'll see it's generally a negative trend in terms of carbon emissions, but what you'll also see is that this also produces an invalid data trend, because it predicts in 2004 that they would have a negative carbon emissions, which is impossible. So that's interesting. So you always have to do the results make any sense? So we're going to look at the forecast. So you'll see, for example, the forecast for these particular periods. And what we want to see is how far are these from the actual 2004 amount. So what we're going to do is we're going to join this table, which has the forecast, and then this table, which actually has the real 2004 amount. So we're going to do a join. We're going to select 2004. We're going to match them on country, and we're just going to include the carbon emission. So we're going to include all records in the primary file. In this case, it doesn't really matter, so we're going to press OK. And then you'll see how far off they are. And we can create a new field. We're going to go to the data. We're going to get append. We're going to create a numeric field, and we're going to call it variance. In this case, we want to have 2 decimal places, and we want the parameters to be carbon forecast minus carbon. And we actually want to do the absolute value. So I'm just going to have to move this around, and we're going to check the formula. So you can see there. Perfect. Maybe we want to do create one other field. So we're going to call it variance percentage. So we want to know, because a country like China or the United States may have a large variance, but it may not be that far off statistically. So we're going to numeric. We're going to go 2 decimal places. Actually, let's go 4 decimal places. And we're going to do variance divided by the original 2004 amount. That's OK, OK, and then you'll see some numbers right there. So really helpful, but we also want to evaluate the trend mapping, which basically assesses how far off the trend. So the larger the number, the worse it is. So you'll see, for example, United States, India, Australia, there's a very low mapping, which is what we're looking for. So we're going to go to this join database. Let's rename it actually. Let's call it actual versus forecast. Oh, I need to close the database first. My bad. Actual versus forecast. And then what we're going to do here is we're going to perform another join. And then we're going to select the second database. We're going to select this trend mapping. In this case, we're just going to include the mapping. We're going to call this actual versus forecast. And we're going to include all records in the primary record. Oh, I forgot to include the matching key. In this case, it's going to be country again. So that's all fine and dandy. But now we want to figure out where is there actually a linear correlation, and where does it actually come up with a useful result. So we're going to go to the extraction. And we're going to go here, and then we're going to go useful forecasts countries. And then our parameters, this is going to get a little bit complicated. So we're basically going to have the variance is less than 50, or let's say the variance percentage actually. The variance percentage, we're going to include that as well. the carbon maybe is going to be less than, let's say, 100, and we're going to put and the variance percentage is going to be less than 10%, and as well, we only really care about countries where it's actually going to have a material impact on the world. So let's look for only countries that have a carbon emission greater than 100 units in 2004. So you press OK, then you'll see useful forecast, and then you'll see that there are only 3 countries that actually qualify that meet all 3 of those criteria that would be useful in terms of using those trend analysis. So for these 3 countries, we probably could expand our analysis to see what the results would be in future years. So that's the final lesson in our lesson set for Introduction to IDEA. So if you have any other questions or comments, feel free to leave them below, and I look forward to hearing from you when I start teaching the intermediate version, where we'll be going over certain scenarios. Thank you, and have a good day.